we will be looking at how to decide whether the graph of a function is curving upwards or curving downwards. And to do that, we need the help of second derivative. Let's look at concavity first. This is a straight line. We call this curving up. So it's like you push the two ends up. So it's concave up. Then for concave down, it's like you push the two ends down. So concave down. So that's how you decide concavity. Concave up and concave down. And it turns out that concave up means second derivative is positive. Concave down came from second derivative is negative. We will try to understand why concave up second derivative is positive and concave down second derivative is negative. F double prime x is less than 0 for concave down, and concave up f double prime x is positive. So we'll try to understand this too. Why f double prime positive will be concave up will be this way. So it can be this way or this way. Concave down means it can be this way or this way. F prime x determines if f is increasing or decreasing. You use f prime to decide f. That's what we have seen earlier. If f prime is positive, you must have increasing f. If f prime is negative, you must have decreasing f. That's what you have. So if f prime positive, it tells you increasing. Increasing, it can be curving this way, or it can be curving down the other way. Both f prime will be positive. If f prime is positive, you only know that the graph is going up when you go from left to right. But it can be curving up, it can be curving down. And then the second derivative will decide is curving up or down. So with f prime and f double prime, you can actually know exactly how to draw a curve, how to sketch a curve. So if you know f prime is positive, you know that either you must draw it increasing. It can be curving up, concave up, or concave down. Then with the help of second derivative, you'll know is which case, curving up or curving down. And here there are four cases. F prime x less than 0 will be decreasing. So it will be these two cases. These two cases are decreasing. Then if f double prime positive, it tells you curving up. So it tells you curving up. So it tells you it has to be this way. If f double prime is negative, it tells you curving down. So it has to be this case. Then if f prime x is positive, it's increasing. It can be curving down, it could be curving up. And then you use a second derivative to decide. If the second derivative is positive, means curving up, so it has to be this way. If the second derivative is negative, means curving down is this way. So you'll find that with the help of f prime and f double prime, you'll know exactly how to sketch your graph. Curving up or curving down, and increasing or decreasing. So basically, it will be these four cases. So that means if you need to sketch a graph of a function fx, you just need to find f prime x, f double prime x. Then you test out the sign of f prime x and f double prime x. Then you will know whether to draw it in which case. Okay, so I can call this case 1, case 2, case 3, or case 4. It will be one of the four cases here. Next we'll be looking at what we call points of inflection. You make a graph look like this. We call A a point of inflection. A a point of inflection if before A, right, the graph is curving down, and after A, right, the graph is curving up. So there's a change in curvature. Then you say point A is a point of inflection. It can be the other way around. Before A is curving up, and after A, right, is curving down. So in both cases, point A is known as a point of inflection. A point C is called a point inflection of the function f if f is continuous at C and there's an open interval containing C such that the graph of f changes curvature from concave up or before C to concave down after C or the other way around. So to have point of inflection means there must be a change of curvature. So we call point C a point inflection if before C, right, the graph is concave up, and after C, the graph is concave down, or the other way around. So which means to test for point inflection, you need to have d2y dx squared changes sign. Because before C concave up, right, meaning if you write the second derivative, so before C concave up means f double prime positive, then up concave down, right, after C, concave down after C. So which means after C concave down, second derivative will be negative. So which means if you need to test for point inflection, you test d2y dx squared changes sign. So to test point inflection, you test d2y dx squared changes sign. Next we shall see how can you use f double prime to test for local maximum, local minimum. Local maximum, local minimum. So suppose f prime C is 0. That means at C the gradient is 0. Then f double prime C is negative. Then f will have as a local maximum at x equal to C. Let's draw in tangent line before C and after C. If you draw a tangent line here, you draw another tangent line after C. After C, you draw another tangent line. So you'll find that the red line has positive gradient because it's tangent this way. Then the blue tangent line here will have a negative gradient. This one is positive gradient. Positive gradient. Then this is negative gradient. So you'll find that from positive gradient, then at C is 0 gradient, then negative gradient. So you'll find that the gradient decreases. So from positive gradient to 0 gradient, so the gradient changes from positive to 0, then to negative. So you have decreasing gradient from positive gradient to 0 gradient, then to negative gradient. So if you have decreasing gradient, means your second derivative must be negative. So that's why you can use second derivative to test for turning point. So for maximum point, you'll find that gradient changes from positive to 0, then to negative. So that means if f double prime C is negative, then you know that it's curving down, right? So it must give you maximum point. Then for the same reason, if f prime C is 0 and f double prime C is positive, you know that it's curving up, right? So it must be a minimum point if f double prime C is positive. If f double prime C is negative, then it must give you maximum point. So we call this second derivative test for local extreme values. So if you need to show a point is maximum point, you show that f double prime C is negative, or d2y dx squared is less than 0. Then to show minimum, you show f double prime C is positive, or d2y dx squared is positive, then you show minimum.